It's now time to introduce Mr. Matt McPhail, Global Director of Systems Engineering at Scale Computing. Matt, are you with us?
I am, David. Thank you so much for having me.
Thanks for being on the event today, Matt. Take it away.
Absolutely. So, everyone, just to wrap up, I wanted to make sure that we had time to talk about something a little bit different when it came to hyperconvergence, and that's actually efficiency. So what I want to do today is I want to build the case for efficiency, talk about where we've come from and where we're going when it comes to efficiency and hyperconvergence in the edge. So, of course, I would be disingenuous to have an extremely long slide deck with multiple different demos and presentations to talk about efficiency. So this will be a quick deck, and my goal is to be done in 15 minutes or less. So by all means, if you have any questions as I'm going through this, feel free to ask them in the chat bar, and away we go. So where did we begin? How did this all start when it came to virtualization and building out a virtualized environment? It really all started with the SAN. The SAN itself was there in order to be able to house the data, be able to connect everything, to be able to become that central point of the 3-2-1 architecture. And how it was connected, obviously, is you've got JBOD underneath, and you've got a specifically firmware file system running on top. That firmware file system is then connected via a network. That way, anything that needs to connect to the SAN obviously can get to it. All of this is then connected with a management layer. You've got a server that handles the management. You've got specific servers that are then connected there in order to be able to then access the data directly from the SAN. All pretty straightforward. But again, what's the first thing that you do when you have that? You've got a specific object store that is then built as a LUN that is then instantiated out to each of the different servers. All of those servers are doing, again, housing that data in order for you to be able to create virtual machines. And you haven't even gotten to the point where you're installing anything yet. So first things first, after you have that LUN instantiated, you're installing the actual underlying software in order to be able to do anything that is remotely associated with virtualization. And with that, you put a file system on it. So now you got a file system on top of an object store connected across the network, on top of an object store file system, then that's connected via JBOD. So whether that's VMFS, whether that is VHDX, it really doesn't matter. You're still running with multiple different layers here. And then the first thing that happens with that virtual machine that's installed is that you create an object store, VHDK, for example. And then, and only then, are you able to create that VM. That VM, of course, the first thing that happens when you have the VM created is that you've got a file system that's created for the OS just so you can run the application. Now, you guys do this all day long, and you don't even probably even think about it. When I was a virtualization admin, I worked at VMware for a number of years prior to coming over to Scale. I didn't even think about this. But the fact is that in order for me to change a period to a comma, my path goes all the way from the application through that first layer of file system, through the object store, through the second layer of file system, through the object store, across the network, through that new object store that's across the firmware layer that then finally connects to the JBOD. 7 steps of hop, latency, and efficiency lost, just for you to be able to change a period of comma. And unfortunately, that doesn't even include the fact that you have to do some sort of mirrored write or some sort of redundancy there in order to make things happen. Thankfully, it's not 2010 anymore. And you guys are on this environment in some form or fashion, but likely you're also moving over, or thankfully you're on this call to think about moving over to a hyperconverged environment because you don't want a complex infrastructure anymore. IT in and of itself is rapidly moving away from that and towards edge computing, towards hyperconvergence, towards being able to do things that our friends that you have listened to on previous conversations have already been able to do. But what we're doing even more is that there are smaller, efficient, affordable solutions that are also needed. And what has happened is that the first iteration of hyperconvergence really didn't change that complexity. It just hit it. So when you look at hyperconvergence, when you have to run in a Hyper-V or VMware environment, what all of our peers do is it looks something similar to this. So now what you're looking at is you've got all of the SAN and the network complexity hidden in a VSA, and for you to be able to, again, change that period to a comma, you're going down through the node hypervisor, across this virtual CPU layer on the VSA, up through the actual local JBOD, through that firmware layer, down through the firmware layer of the VSAs, and onto the virtual disk. Now it has to be committed. So you've got to go back through all of those layers again in order for that write to be committed. Now, unfortunately, that write needs to be mirrored. So that has to go through the network, back over through a different node hypervisor, down again through the VSA layer, across that virtual CPU, up through the JBOD, through the virtual firmware of that VSA, and down across the virtual disk. And again, unfortunately, if you're mirroring this for proper storage, you're going to have to make a commit once again. And it has to go through all of these layers. Now, all the friends that you've talked with before now that have been on this call before me, it's not their fault that they have to do this. But the reason why is that in order for this to happen is that they have to put VMware, they have to put Hyper-V, they have to put a hypervisor that they cannot touch because it's closed source in a box. And the efficiency lost by having to put it in a box is huge, as you can see here, because there are 14 different hops for you to be able to change a period to a comma. Instead of, what you could do is build in a layer of efficiency that only includes the hardware and the software that you need. Specifically away from the VSA, which is great for Fortune 500, but it's not efficient for the edge, and it's really not efficient for hyperconvergence in general. What you're looking at is taking all of that complexity, taking out all the pieces that you don't need anymore, the management layer, the servers, any of the extraneous hypervisor, the software itself, and include it all into a layer where the VM talks directly with the storage across the network and mirrors the data easily across a general data store, just like it's direct attached. So now what you're talking about, in order to change a period to a comma, you are actually going one hop across the network, two hops, and then you're doing a committed write on another disk on another node. So you're going from this on the left-hand side to that, where, again, they're having to cover up a lot of inefficiencies with caching, with SSDs, with the ability to actually run in a hypervisor that is a closed source system. So you're using anywhere from 12 cores and up to 300 gigs worth of RAM for an entire cluster, to anywhere of a fraction of a core to 12 gigs of RAM for a truly efficient environment that is set up so that you can have all of the VMs talk directly with the hardware. So it's really a case of you get what you pay for. You are trying to maximize the amount of hardware spend that you have and get as much performance out of that hardware spend. That way, you're able to do more with less. Another way to look at it is comparing the left-hand side. This is the amount of writes that you're doing on the left-hand side to the amount of writes that you're doing on the right-hand side. So when you start getting efficient, you start moving away from problems like this. Added complexity, which equals added costs because you've got multiple vendors, you've got multiple different support contracts. The integration time is tedious. And with that, the expertise that is associated with that tedium is even higher. The scalability issues become apparent. The licensing becomes an issue as well. And quite frankly, if you're talking about DR and backups, now you're having to make decisions on where you want any extra money going to and how to do that the best way. As opposed to our whole idea around this where if you build it efficiently, you've got a single vendor, you've got no integration time, you've got no infrastructure expertise needed. I actually taught my 4-year-old daughter how to create a VM on the system. The system itself really scales well, and you don't have to worry about licensing, and everything's built in. So it's cool because now what you're talking about is you've got an efficient solution that rolls into a simple solution as well. So customers start getting interested. So I got a guy in the UK who actually made his setup 10 times faster. He made his maintenance a quarter of the time. His recovery was 10 times faster. And quite frankly, he was able to save over $1 million in his environment because of the fact that he just needed less hardware and less operational costs in order to run the system, which is great. And it really validated what we're doing. And as we continue to do it, because we've been doing this for 10 years, we started getting more. We started getting more validations from some of the trusted advisors. And then from there, we actually started getting awards. And we started getting more industry validation. And we've gotten great validation from the actual tech media as well to be able to do this. All because we wanted to make this efficient and simple as a single pane of glass, anywhere from a edge deployment all the way to a multi-system, multi-cluster management deployment, where you take one of the retail deployments that we have that has thousands of different sites, they can get to it all from a single knock. And all because they wanted efficiency. So why does this matter? Why do you care? It's because you can actually eliminate a lot. You can eliminate the nested files upon file systems upon files upon file systems that showed you at the beginning. The fact that it's 60% more efficient means you're actually saving 60% of the cost, and you can fully eliminate the need for software and SAN. You're not just virtualizing it away. You're not just using a VSA or controller VM. More importantly, you take your current environment, whether it's hidden this way or it's built out this way, and you just simply move it to something that makes more sense. Only what you need and only as efficient as a direct connection would allow. So with that, I'm at my 15-minute mark. So I want to give some time for questions, but definitely look us up. We've got info on the web, on email, on Twitter. By all means, I really appreciate the time. So, David, I will turn it back to you for any questions that are available.
Yes, Matt, great presentation, very compelling, and also very efficient. So I like that. I'm sure the audience did as well. We do have some questions here for you. So let's see. First one that came in, Phil is asking, what hypervisors do you support?
Great question. Thank you, Phil. So hypervisor is KVM. It's actually built in to the underlying software. So we leverage our own software called HyperCore OS, but it leverages Red Hat's known hypervisor KVM. It's just something you don't have to be an expert in, though. Everything is done through the UI, and in fact, again, you don't need any training on KVM whatsoever.
Very nice. Yeah, I've used scale computing myself, and it is just super easy. So I want to call attention to a poll question on the screen for the audience, and it should say, what additional information would you like about the scale computing solution? So make your selections. I'll just leave that up, and we want to make sure we get you additional information if you'd like it. Another question that came in, Chris is asking how well or how easy is it to move virtual machines from VMware to scale computing?
Great question. This is something we do every day, because every single instance are you going to get into a situation where, okay, you're going to need to take from an existing environment and move it over to a newer environment. Thankfully, due to the open virtualization format that VMware set out 2008, any VM can run on any other hypervisor. There's really no vendor lock in there. With a quick convert, it is not hard, and we've got tools that enable you to do it. We got tools that enable you to do it with minimal downtime as well.
Nice, nice. Well, that sounds easy. David is asking, how robust are the APIs for Scale's hypervisor?
Great. We actually leverage multiple different APIs depending on what your needs are, and we've got an entire API stack in order for you to be able to use. We love for you guys to be able to have nerd knobs as you need. Again, we're trying to be a simple solution, but anything from the API is able to run just like anything that you'd be able to do through the UI. So that's our goal there with the API stack. But thank you for that question. Okay, excellent. Another question, they're asking, what hardware platforms do you work with, or does this run in the cloud? Great question. So this is an on-prem solution, although we do have partnerships with cloud providers such as Google. We also have multiple different hardware vendors. So we do run versions on Supermicro, but our biggest hardware OEM has been Dell. Has been Dell in the past, but right now it is Lenovo. So Lenovo has been a great partner. They've definitely invested a lot of time and a lot of resources into us, and we're happy with the hardware that they've provided, anywhere from a very small edge style of hardware all the way up to a big beefy node that's available for a very large deployment. We've got other OEMs such as NEC and Fujitsu that we're working with, but all of those just show that we can run on hardware and on just straight software as necessary.
Very nice, yeah. Another question here about Edge. You mentioned Edge. They're asking, is this something that Edge deployments are using today?
Great question. So, as noted in my presentation, the large retail deployments I talked about, a couple thousand sites, that actually is an Edge deployment. They're leveraging our multi-site management suite. They're actually leveraging this on very small Lenovo boxes, and this is something that they have deployed with specific features that have been catered for Edge-style deployments, such as auditing, such as being able to have multi-user management, and there are other tools in place to be able to really focus on Edge. There's an entire presentation, obviously, out there on Edge that we could review on, but the answer is yes. This works great on Edge because of the efficiency piece.
Okay, nice. Question from Chris. He's asking, what's the minimum number of nodes in a cluster?
Great question. So the minimum number of nodes that we can support are 1, but that's not a cluster. The minimum number of nodes in a cluster are 3, and the reason is because of quorum. You always have to have a tiebreaker. If someone's trying to sell 2 nodes, that really doesn't create a situation where you're getting the most out of your hardware because of quorum and because of having to have an idle node or a node that's only at 50% or less.
Got it. That makes sense, yeah. Do you recommend people do to get started?
So the great thing is that we were always happy to give demos. So reach out to your local partner, reach out to a sales rep if you know who they are, but more importantly, just go to the website. You can sign up for a weekly demo directly off the website. A couple of my guys actually give the weekly demo, and they're more than happy to answer specific questions. We actually make the weekly demo small, so we will not allow more than about 10 people on that demo in order to ensure that you get your questions answered. So feel free to go to the website and just sign up. Nice.
And I've been on those demos before. Actually, it's super easy. That's all I can say about scale computing is everything just seems super easy and efficient, like you said. So I think that's all the time we have for our Q&A section, but it's been really great having you on the event today. Thank you, Matt.
Thank you very much, everyone. Thank you, David.